Hey, good morning from NASA's Wallops Flight Facility here on the eastern shore of Virginia. We are on tap this morning to launch a Terrier Improved Orion suborbital sounding rocket carrying student experiments through the RockOn, RockSat-C and Cubes in Space programs. Everything has gone pretty good this morning. Everything is checked out on the payload and the rocket. Weather is cooperating. As you can see there, we have really good skies. The seas have calmed down since yesterday, and so hopefully we'll be able to launch at 5:30 at the opening of the window.
Three, you might as well.
Coming up at the T-minus 12 minute mark, we'll be providing the preliminary settings for the launcher. And then following that up at T-minus 10 minutes, we should be hearing whether or not we are good to go for launch and that the impact area is clear of any boats in the area. And then we'll begin our terminal count beginning at the T-minus 8 minute mark. For the mission today, we have approximately 60 university and community college experiments that will be flying through the RockOn and RockSat-C programs. These are conducted in conjunction with the Colorado and Virginia Space Grant Consortia. In these programs with RockOn, the students get their first tap at learning how to build experiments that would be flying on suborbital vehicles. And then RockSat-C, basically the students have graduated and gone on to a little bit more complex system where they are actually developing their experiments that they'll be flying. So we'll have 7 of those experiments flying today, and we have approximately 39 of the RockOn experiments that are flying. Participating in the RockSat-C program this year, we have Hobart William Smith Colleges in New York, Old Dominion University from Virginia, Temple University in Pennsylvania, University of Delaware in Newark, Southeast Louisiana University in Hammond, and we also have West Virginia Collaboration, which is a group of universities throughout West Virginia. And then finally, we have University of Puerto Rico joining us. Also on hand today, we do have approximately 140 students, and you can probably see their cars lining up as they arrive to view the launch. So we are glad this year, now that we are...
TDR, so.
Go for TD.
Yeah, we lost track on our last chaff balloon. We got to get another one up here. So we're going to be cutting it close for actually getting final settings by the time you need them. So we might need to hold at some point. But we're going to work it.
TD copies.
So I was saying we are glad that the students are able to be here. This is the first time in 2 years that since the pandemic arrived. So the last time we had students here for the launches were in 2019. So we were glad that things were able to work out and the students were able to attend the launch today. The final group of experiments that we'll be flying is called Cubes in Space. We have approximately 80 of those experiments that will be flying in the nose cone of the rocket. And Cubes in Space is a program for middle and high school students to put passive experiments on board the rocket. And this is conducted in conjunction with a partnership between Colorado Space Grant, iDoodle Learning, and also National Langley Research Center is involved in this program. so that we were glad to also be able to have these students be able to fly with us today, or at least their experiments. Students won't be flying. So the launch was originally planned for yesterday. However, during testing on Wednesday, we did experience a little payload issue, and so that got fixed Wednesday afternoon. But then it comes out that the weather was not really acceptable for launch. We had low clouds in the area yesterday with a little bit of rain, and also the seas in the recovery area were a little bit on the rough side, so it would have been difficult for us to send a boat out to recover the payload. So we did postpone the launch, and it was a good call, and so everything is looking weather-wise really good for today's launch. We'll be flying today on the Terrier Improved Orion. This is a 39-foot rocket with the payload. It's a solid fuel vehicle, unguided. So it's kind of like shooting an arrow at our target. Once we ignite the rocket, we really don't have any control where it's going. So we adjust for the winds that you heard them talking about, flying the chaff balloons. It gives us the winds up above us, and that way we can point the rocket to make sure we can hit that target in space that we're looking at. We're looking to go about 72 miles altitude. Again, this is a very fast rocket. The rocket will clear the rail in about 0.4 seconds. The Terrier motor, the first stage motor, will burn out at 5.2 seconds. We then coast for about 10 seconds. Second stage Orion ignites at 15.
RSO.
This is RSO, go ahead.
Provide pad 250K launcher preliminary wind-weighted settings.
Preliminary wind-weighted settings are as follows. Azimuth 126.1, elevation 83.2.
126.1, elevation 83.2.
Good readback.
Copy LC, ROA.
LC?
Set 50K launcher to preliminary settings. Confirm settings. Azimuth 126.1, elevation 83.2.
Good work.
TD RSO.
Go for TD.
With the delay in the last balloon, I'm going to suggest that we hold at the 10-minute mark, where we have the point in the count to do so, and hold for 5 minutes.
TD concurs. Programmer, you hold at 5.
Hold at
10.
5.
Hold at 10.
Copy. 50K launcher set to azimuth 126.1, elevation 83.2.
Copy. Check 9-6.
And there you go. We'll be holding at T-minus 10-minute mark, and allow us to just to make sure that those winds are measured right, that we do have the rocket pointed in the right direction.
Clock held.
All stations, this is TD. We're in a hold for about 5 minutes for wind waiting activities.
PM copies.
given the breakdown again for the launch today, the flight, that rocket will clear the rail at about 0.4 seconds after ignition. Terrier motor first stage burns out at 5.2 seconds. Second stage is Orion, that ignites at 15. And the Improved Orion will then burn out at 40. The payload and the rocket will continue on. We're looking at a peak altitude of about 72 miles. Then the payload will come down by parachute and expected to land in the Atlantic Ocean about 41 miles from Wallops. It will be picked up by one of our local boaters and then returned back here to Wallops. And expect that everything works out right. We should be having it back here around noon. And then the students that are here will receive their experiments, and they'll be able to start digging into them and see how things went.
RSO TD on 1.
RSO, go ahead.
Yeah, RSO, I'm going to instruct the programmer to pick the clock up at 0925 Zulu. Any issues with that?
I don't believe so. I think we should be good with that.
Okay. Let me know if something comes up.
Will do. We're looking good.
Programmer TD on 1.
Go ahead.
Yes, sir. Can you pick up the clock at 0925 Zulu?
Copy that, 0925.
And so we'll be picking up the countdown here in about 3 minutes. Targeting a launch at 5:35 a.m. Eastern Time. This is a busy launch week for Wallops this weekend. And actually we have, in addition to the launch this morning from here at Wallops, we are targeting a possible launch this afternoon from Sweden with our balloon program. And then Sunday morning will be the launch of the first of 3 rockets that we have going from Australia this summer. Launch time in Australia will be at 9:14 a.m. Eastern Time. And that launch will also be streamed. You can watch that launch at the Equatorial Launch Australia's YouTube site beginning around 8:30 a.m. Eastern Time. That rocket will be launched from Arnhem Space Center in the Northern Territory of Australia. And we're picking up the count in about 30 seconds.
Ten minutes and counting.
RSO TD on 1.
This is RSO. Go ahead.
Can you provide the status of the impact area clearance?
Inward. We are good to go with impact area clearance. On the impact area clearance.
TD copies. Check 97.
And there you hear it. In addition to the weather looking good, the avoidance areas downrange are also clear for launch today.
TDPM, permission to begin terminal count.
TD concurs.
Oh, this is ROA. This is NRW-6183 Terrier Mark 12 Improved Orion launching from Pad 2 50K launcher. Please stand by for station checks. All stations should announce status as green or red on Channel 1. RC,
RC green.
MNO,
MNO green.
Programmer,
Programmer green.
LWO,
LO green.
SCO,
SCO's green.
LC,
LC green.
PLC,
PLC green.
LPM,
LPM green.
MM,
MM green.
SRPO,
SRPO green.
RSO,
RSO green.
PM,
PM's green.
TD.
TD's green. All stations are responsible for reviewing the go, no-go criteria listed in the OD. Only stations annotated with an asterisk in the previous step are permitted to call hold. All other sites should report red. Check 101.
MNO PM 1. MNO PM channel 1.
Go ahead, PM.
Confirm timing switches for high-speed cameras are enabled.
Timing switches for high-speed cameras are enabled.
Check 102.
RSO, ROA.
This is RSO. Go ahead.
Provide Pad 2 50K launcher initial wind-weighted settings.
Initial wind weighting settings are as follows. Azimuth 126.6, elevation 83.1.
Azimuth 126.6, elevation 83.1.
Good readback.
LC, ROA.
LC.
Set 50K launcher to initial wind-weighted settings. Confirm settings. Azimuth 126.6, elevation 83.1.
Didn't work.
And this morning's launch is expected to be seen in the Wallops area, mainly Eastern Shore of Virginia, Lower Eastern Shore of Maryland, and Southern Delaware. Since this is one of our smaller rockets that we launch here at Wallops, and also we do have the sun coming up.
50K launcher settings are azimuth 126.6, elevation 83.1.
Copy, check 104.
And if you are watching the stream and expect to go out and try to catch the launch in the area, make sure you account for the time difference variance, and that usually you have about a 30 to 40 second time difference from the events that you see on the stream to those actually happen. So make sure you get out early to catch the launch. Coming up on T-minus 5 minutes.
T-minus 5 minutes.
PLC check 106.
RCPM channel 1.
Go ahead, PM.
Interrogate transponder, verify good 5 codes.
In work.
And the vehicle is now on external power.
RSO, ROA. Provide pad 2 50K launcher final wind weighted settings.
There are no changes to settings. Final wind weighting settings are as follows. Azimuth 126.1. Elevation 83.2.
PMRC. Good 5 code.
Copy all. Check 107.
RSO azimuth 126.1. Elevation
Scratch
83.2.
that. Azimuth 126.6. Elevation 83.2.
Copy.
83.1. Excuse me. What is this written down?
LC, ROA.
LC.
Verify 50K launcher final wind weighted settings are azimuth 126.6. Elevation 83.1.
50K launcher is currently set. Azimuth 126.6. Elevation 83.1.
Copy. Check 109.
PLC check 110. PLC check 112. PLC check 113. PLC check 114.
RCPM Channel 1, confirm transponder good and no change on internal power.
And the vehicle is on
Transponder is good. No change.
vehicle is on internal power,
Check
and the student
111.
experiments have been activated.
T-minus 2 minutes. One minute.
Check 117. Payload is go.
$30 seconds.
Terrier armed.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Radar 18 is tracking. Plus 10. Radar 3 is tracking the booster. Plus 20. Plus 30. $18 and 5 are tracking the payload. Radar 3 is tracking the booster. Plus 40. Plus 50. One minute.
PMR, so are you going to want a balloon post-launch for analysis?
I don't see a need to right now.
Copy, thank you.
And so this morning you did see a good launch this morning of the Terrier Improved Orion with the RockOn, RockSat-C and Cubes in Space student experiments. The parachutes are expected to deploy during the descent approximately 7.5 minutes after launch. Then again, the payload will descend, land in the Atlantic Ocean about 41 miles out, and we'll go out and pick those up with a local fisherman. We'll pick those up for us, bring us back to the docks at Chincoteague, and allow us to bring the experiments back here to Wallops for the students to receive their experiments later today. So launch time this morning was 5:35 a.m. Eastern Time. Next launch from Wallops won't be until August 9th, and that will be the RockSat-X, which is a continuation of our student programs. The rocket will be a Terrier Improved Malamute, so it'll be a little bit larger than the one we flew today. It also will be an early morning launch. And the experiments in the RockSat-X program are a little bit more complex than those flown in the RockSat-C program, and that the students are also given a little bit more weight that they can use, and also their spacing that they're provided is a little bit larger. So again, the next sounding rocket launch for NASA is actually this Sunday from Australia at the Arnhem Space Center, operated by the Equatorial Launch Australia, and that will be shown live, streamed live on the Equatorial Launch Australia's YouTube site, beginning at around 8:30 a.m. Eastern Time. Launch is scheduled for 9:14 a.m. Arnhem Space Center is about 13 and a half hours ahead of us, so it will be a nighttime launch in Australia.
Go ahead.
Are we free to lower the launcher?
Stand by.
SRPO TD.
SRPO.
Do you guys want to take any measurements of the launcher?
Standby 1. PM SRPO on 1.
Go for PM.
Does RC have an apogee?
RCPM, do you have an apogee?
Standby PM.
PM copy.
PMRC.
Go.
371,934.7 feet.
Please repeat that.
371,934.7 feet.
Copy 371,934.7 feet.
Good readback.
SRPO copies, thanks.
So there you heard the apogee. So we're looking at about 371,934 feet, which is approximately 70 and a half miles altitude for our peak altitude for this flight, which is pretty close to what we predicted it would be. And so that concludes today's coverage of the Terrier Improved Orion rocket suborbital launch from Wallops, carrying the RockOn, RockSat-C and Cubes in Space student experiments. Again, next launch from Wallops will be the RockSat-X student experiments on a Terrier Improved Malamute. Launch will be early morning again, just after sunrise on August the 9th. Thank you for joining us and have a good summer.
TDS or PO on 1.
Go for TD.
Yeah, you can lower the launcher.